Hello guys, welcome back to my class with me, Mr. Rois. In the previous meeting, you have learned so many integrals, right? Indefinitive integrals and then definitive integrals as well. And then you know that there are several functions that we can find its integrals. Why? Because you know that in the grade 11, before you already study about differentiation, right? For example, we have the kind of functions such as exponential function and also the reciprocal function, right? So today we are going to learn and discuss about these two types of function and how to find this integral. So let's find out. Here we have first the integration of exponential function. So here, as you can see, how we can find the integration of this exponential function. All right, so you know that the derivative or the differentiation of exponential function here, the derivative of e to the x equals e to the x dx. All right, so how we can find the integration of e to the x dx? Okay, the answer is, of course, it will be e to the x plus c, right? So if we write to find the integrals, it will be e to the x dx, e to the x plus c. Right? So, because you know that integration is just antiderivative, right? So, if you can find the derivative of a function, meaning you can find also its integral, right? So, it's just simple like this to find the integration of e to the x dx. And then, how about if the exponential or the index is not only x? All right? So here you know that the derivative or the differentiation of e to the ax plus b equals e multiplied by e to the ex plus b dx. Okay, you know that these terms is similar with the function, right? But how about a here? You know, if you remember the chain rule, all right, the index of this exponential function, you need to find its derivative. You know that the derivative of ex plus b is equal to a. So by using chain rule, you just simply multiply this exponential function by the derivative. Okay? And then how to find its integrals? Alright, so the same technique with e to the x, finding e to the x, the integration. So integrals of e to the ax plus b, all right, it will be, okay, if before dx, I'm sorry, it's dx. If before we multiply, now this one, we just divide, right? So this is the opposite. So remember, the integration is the opposite of integration, right? So we can write as 1 over a. What is a? Chain rule before, a to the ax plus b, the derivative is a. So, meaning you just simply divide by a, right? And then a to the x plus b plus c. Or you can rewrite as e to the, e to the ax plus b over a plus c. Alright, so this is how we can find the second forms of exponential function. Okay, now to understand more about this, let's see the examples. Here we have the integration of e to the 3x dx. So, by using which one, the first or the second? Look the index here, 3x, it means we use the second, right? So, we just simply write as Remember, the derivative of 3x is 3, so it will be 1 over 3 multiplied by e to the 3x plus c. Alright, don't forget. Second, how about this? How about if the index is 4 minus 5x? Remember, this one, we can use the second again, because it's not just simple only e to the x, so you use the second here. So here, remember, the derivative of 4 minus 5x, it should be minus 5. So 1 over minus 5 times e to the 4 minus 5x plus c. So here, you can rewrite as negative of e to the 4 minus 5x over 5 plus c. Okay. The last, we have integration of 9 times e to the 3x minus 1. How about this? Again, don't worry. If we have coefficient here, just take the coefficient out of integration, and then we just rewrite like this. Integration of 3 e to the 3x minus 1 dx, right? So it will be 9 times the derivative of 3x minus 1. It should be 3, right? So just 1 over 3 e to the 3x minus 1 plus c. Or if we simplify, 9 multiplied by 1 over 3, so it's simply 9 divided by 3 is 3. So 3 e to the 3x minus 1 plus c. That's it. So this is how we can find the integration of exponential function. Now, how about the second? Alright, we have the integration of 1 over ax plus b, the reciprocal function. So, how to find it? So, firstly, we need to take a look the differentiation first, right? So, here we have the derivative of ln x. What is ln x here? Or ln x? It's natural logarithms, right? So, you know that the derivative of ln x or ln x, it will be 1 over x dx. Of course, with x positive. Alright? And then the second, we have also the derivative of ln or ln ex plus b equals the same. A is the derivative of ax plus b. So using chain rule again. Okay. So the derivative of ax plus b is a. So we just put a here and then over ax plus b over its function. So remember, when you differentiate natural logarithms, you just write down like this, the derivative of the function and then over the function itself. All right. Of course, with since this one is fraction or reciprocal, the denominator should be defined as positive like this. And then, how to find the integration of 1 over ax plus b? Firstly, we need to find this integration of 1 over x first, the simple one. So the integration of 1 over x dx, it will be ln x, right? So it's ln x. And you know that integration is just the opposite operation of differentiation, right? With the same definition, x should be positive. How about this? How to find the integration of a over ax plus b dx? It seems difficult. Let's find out. Okay, if you know that if 1 over x ln x, and you know that this, in order to find the antiderivative here, you just focus with this result of derivative, and then you must think that we need to take this as the result of integration, right? Okay, and then you just simply write here, or I can write it down. We don't have the space of this, so the integration should be, I'll just write down here. Okay. All right, so this one, it should be ln ax plus b. How about a here? We missed one step actually, sorry. So we just write down as a over 1 over ax plus b. Because we need to find the integration of this, right? 1 over ax plus b. So this one should be, I'll just write down here, a over, or a multiplied by, if this one is, you multiply by the derivative, look here. So here you need to divide, right? So the derivative of ax plus b, here is a, so 1 over a. Remember, a, this one is the coefficient of this, right? The constant, I mean. And a here is the derivative of ax plus b. Okay, and then ln ax plus b plus c, don't forget. Okay, here you can just look, a divided by a, here it will be 1, right? So it's 1 times ln ax plus b plus c. All right. So, or if we simplify, it will be ln ax plus b plus c. So this is the derivative of this. So by this you can see that the derivative of 1 over ax plus b, it will be this. Right? It will be this. Okay, since a is constant of this before. Alright, so the integration of this should be this box. Yeah, 1 over a ln ax plus b plus c. Alright. So one example to make it more interesting. So how about if we have like this? Again, the same, yeah, we have a over ax plus b. So you just take 6 out and then we have 1 over 2 minus 3x. Okay. So here it will be 6 multiplied by the derivative of 2 minus 3x. It will be minus 3, right? So 1 over minus 3 and then ln or ln 2 minus 3x plus c, don't forget. So in the end, if we simplify, 6 times 1 over minus 3 is minus 2 ln 2 minus 3x plus c. Alright, so this is how we can find the integration of exponential function and the reciprocal function. Alright, so that's it for me. I hope you understand with my explanation. If you don't, you may see me and ask me in Zoom meeting or LMS. Alright, thank you very much.